elastic and inelastic collisions. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It is very important to the continuity of this channel. In physics, collisions occur when one object strikes another. In general, collisions include any strong interaction between bodies that lasts a very short period of time. For example, car accidents, balls colliding on a billiard table, neutrons hitting atomic nuclei in a nuclear reactor. If the forces between the bodies are much larger than any external forces, as is the case in most collisions, we can neglect the external forces entirely and treat the bodies as an isolated system. Then, momentum is conserved and the total momentum of the system has the same value before and after the collision. Based on whether kinetic energy is conserved or not conserved, collisions are classified as elastic or inelastic, respectively. A collision in which kinetic energy is conserved is called elastic. A collision in which the total kinetic energy decreases is called inelastic. There are many outcomes of an inelastic collision, but here we will only treat perfectly inelastic collisions. In a perfectly inelastic collision, kinetic energy is not conserved, and the two objects stick together after the collision. So their final velocities are the same. Consider two bodies moving with known initial velocities along a straight line as shown in figure. If the two bodies collide head-on, stick together, and move with a common velocity v after the collision, then the collision is perfectly inelastic. Let's look at what happens to momentum and kinetic energy in a completely inelastic collision of two bodies. Because the two bodies stick together after the collision, they have the same final velocity. So, conservation of momentum gives the following relationship. The total kinetic energy after this completely inelastic collision is less than before the collision. So the change in kinetic energy of the system is the kinetic energy of the system after collision minus the kinetic energy of the system before collision. A car A with mass 1,800 kg is traveling eastbound at 15 meters per second, while a compact car B with mass 900 kg is traveling westbound at 20 meters per second. The cars collide head-on and stick together. Find the change in the kinetic energy of the system. To find the change in the kinetic energy of the system, we need to calculate the velocity after collision. Then we use the conservation of momentum. Substitute the values and solve for the final velocity. We now use this final velocity to find the change in kinetic energy. The lost kinetic energy is transformed into other forms of energy, such as thermal energy, deformation energy, and sound energy. In an elastic collision, both momentum and kinetic energy are conserved. Now consider two bodies that undergo an elastic head-on collision. In this situation, both the momentum and the kinetic energy of the system of two bodies are conserved. We can write these conditions as follows. The bumper cars A and B each have a mass of 150 kilograms and are coasting with the velocities shown before they freely collide head-on. If no energy is lost during the collision, determine their velocities after collision. If the collision is elastic, then momentum and kinetic energy are both conserved. The solution of this problem is a matter of solving two equations, the conservation of momentum and conservation of kinetic energy, for two unknowns, the final velocities of the two cars. Since the bodies have equal masses, we can cancel the masses. We must solve these equations simultaneously. We isolate the velocity of mass A in the first equation and substitute it in the second equation. After simplifying, we get this quadratic equation. Solving for the two roots, we get minus 2 meters per second and 3 meters per second. Since minus 2 meters per second refers to the velocity of B just before collision, then the velocity of B just after the collision must be 3 meters per second. Substituting this result into equation, we obtain the velocity of A just after the collision.